All right, Algebra 2. So we're going to finish up Unit 6. This is on summation notation. So we have this new symbol that we're going to be looking at. And so this symbol comes in when we want to find the sum of a series, right? And so it has that kind of look like an E. It's a Greek letter, sigma. So we can see how it is used. So let's say we have this series 3 plus 4 plus 5 plus 6. We want to add those numbers together. Well, instead of having to list out all the numbers like that, or even if there was 100 numbers and we want to add them up, instead of having to list them out, we can use this notation that's on the right side of the series to write it instead. And so anytime we see that sigma notation, that means that we're adding up the numbers in the series. So what do each of those arrows represent? So there's three parts to writing and understanding what this notation means. So n equals 1 on the bottom, that just means that if we were to take 1 and plug it into a rule, we would get the first term of a series. Okay, the first term that would be listed. So in this case, it's 3. 3 is the first number. And so that's all it's saying. So n equals 1 is allows us to get the first term. Okay. Now this n plus 2, that's the rule. So that's the an rule or formula for this series, 3 plus 4 plus 5 plus 6. Now we can see that if we were to take 1 and substitute it in for n and add 2, 1 plus 2 gives us 3, which is the first term of the series. And then the 4 at the top tells us how many numbers. Okay, so it's the number of terms that we're adding up. All right, and so we can see that 3 plus 4 plus 5 plus 6, there's 4 numbers there, and so that's why it's 4 at the top. So 4 terms. All right, so let's see how we can use that, and we'll find the sum. All right, so number 1 says find the sum of the series. So they give us the notation there. And the first thing we want to do is identify, is this an arithmetic rule, AN rule, or is it a geometric rule? So the way that you can tell if it's arithmetic, it has to be in the form of y equals mx plus b. Okay, it has to be in the form of y equals mx plus b. And if it's geometric, it has to have that exponent. Okay, the variable has to be up in the exponent. So this rule of negative 2n plus 1, that is in the form of y equals mx plus b. It has a slope of negative 2 and a y-intercept of positive 1. So this is arithmetic. And if it's arithmetic, that means it has a d value. If it was geometric, it would have an r value. So the d value is the number that we're adding or subtracting to get from one term to the next. And that's the d value, if you remember, is the same as the slope. And so in this case, it's negative 2. All right, so now we want to go ahead and find the sum of the series. Since we know it's arithmetic, we have a sum formula to do this. All right, so we'll go back and look at our sum formulas for arithmetic and geometric. Well, for arithmetic, it's the n over 2 times a1 plus an. So we want to know how many terms are we adding up. Well, if you take 1 from the bottom, n equals 1, to 20 at the top, we can see that there's going to be 20 numbers. So we're looking for s sub 20. And so our formula is n divided by 2, so it's going to be 20 divided by 2 times a1, the first term. Well, to get the first term, all we have to do is take 1 and substitute it in for n, and then simplify it. So negative 2 times 1 is negative 2, plus 1 is negative 1. So the first term is going to be negative 1, plus, now we have to get the last term, or the 20th term. Well, to find the 20th term, we take the top number and plug it in for n. So negative 2 times 20 is negative 40, plus 1 is negative 39. All right, so now we just have to simplify this. 20 divided by 2 is 10. Negative 1 plus negative 39 is negative 40. If we multiply those together, we get negative 400. So that would be the sum of the first 20 numbers of this series. All right, let's do B. All right, so B is asking, is this arithmetic or geometric? So again, we can see it's arithmetic because it is in the form of y equals mx plus b. There's no exponent. So this is arithmetic. And because it's arithmetic, it has a d value, which is the slope. In this case, it's 5. All right, so now let's go ahead and find the sum. Again, we're just going to use that same formula that we did before because it's arithmetic. So we're looking for S of 30 this time, 30 terms. So now we're going to go 30 divided by 2. Now the first term, we're going to plug 1 in for n. So 5 times 1 is 5. Plus, now we'll find the 30th term, plugging 3 in, times 5 is 150. All right, so let's simplify this. 15 times 155. And so I'm going to take my calculator. So that's 2325. All right, so C. So our rule is 6 times 2 to the n minus 1. Now, because there's an exponent for the variable, this is going to be geometric. And if you remember the explicit rule for geometric, that's the an equals a1 times r to the n minus 1. All right, that number is your a1 term, and this number is your r. So that means r is equal to 2. All right, so now we have a finite geometric formula that we can use. So we're looking for S sub 10. And so the geometric finite formula is the a1 times 1 minus r to the n over 1 minus r. So a1, we know is 6 times 1 minus r is 2. We're raising it to the 10th power. And we're going to divide it by 1 minus r again, 1 minus 2. All right, so just like before, we're going to simplify the denominator real quick. 1 minus 2 is negative 1. And now we're going to throw that in the calculator. So 1 minus 2 raised to the 10th divided by negative 1 times 6. 6,138. All right, and then let's do D. So we see our rule is 3 times 2/3 to the n minus 1. Again, since we have that exponent, that's a variable, n minus 1, we know this is geometric. Again, that number in front is the a1 term. The number inside the parentheses is r, so r is 2/3. Now, because of the infinity at the top, that tells us that this is not a finite series, it's an infinite series. So we have a formula that we can use for infinite. So that's the S infinity equals a1 divided by 1 minus r. So a1 is 3, 1 minus r, 2/3. All right, so then 1 minus 2/3, well, 1 is the same as 3/3, and 3/3 minus 2/3 is 1/3. And 3 divided by 1/3, you can put that in the calculator, but 3 divided by 1/3 is going to be 9. So that's the sum of the series, 9. All right, and then the last one is number 2. We're going to do the reverse. They give us the series, and we're going to write it in sigma notation. All right, so the first thing we do is write the symbol, or draw the symbol. We're going to always start it with n equals 1. Now on the top, we have to come up with, see the number of terms that we have. So we count them up. We can see we have 1, 2, 3, 4, 5. So 5 goes on the top. And then off to the side, we're going to write the rule. So we have to see, is this arithmetic or geometric? And so to get from 3 to 6 to 12 to 24 to 48, we can see we're multiplying by 2. So this is geometric, multiplying by 2. All right, so there is an R value. It's 2. All right, and so our rule is going to be a sub 1, which is 3, times R raised to the n minus 1. All right, and that's all you have to do. All right, B, to get from 18 to 13 to 8 to 3, looks like we're subtracting 5. So this is arithmetic, and so D is negative 5. So our symbol, n equals 1. The number of terms we have is 4. And now we have to write the rule. All right, so if you remember our explicit formula for arithmetic that we can use, a sub n equals a1 plus, with plus 1 minus 1 times d, substituting the numbers in. 18 is the first term. D is negative 5. No, that's a negative, not a subtraction. So distribute, and then combine my terms. So that's negative 5n plus 23. So you don't write the a sub n equals. You just write the rule. All right, and then the last one, C. Sigma notation. All right, so to get from 100 to 50 to 25, looks like we're dividing by 2, but that's the same as multiplying it by half. So this is geometric. N equals 1 on the bottom. Now, because of the dot, dot, dot after it, this is going to go on for forever, so it's infinity at the top. And then our geometric rule is just like A, the first term, 100, times R, raised to the n minus 1. Right? And that's it.